This is live. Oh yeah, it seems to be. So yeah, I basically wanted to kind of follow on from where Charles got to in terms of the overview of OpenDaylight, but then drill down on one specific kind of application area, which is BGP. As I mentioned just now in the Q&A though, it's not pure BGP, so I'm using a few different plugins. Also, to some extent, trying to segue a bit to the Panda presentation that we've got later this afternoon, kind of seeing where that fits in with all this. I mean, my background is very much in the service provider, so I've been at Cisco like 6 years, but before that I generally worked at SPs, so most recently at British Telecom, and doing kind of large-scale service provider networking. But my original, when I started my career, it was as a software developer writing C code, so this whole kind of SDN thing's been interesting in terms of coming back to coding. So I want to give a quick overview of what BGP and PSEP is in OpenDaylight, and then go into 3 use cases. I'm going to demo 2 of them. Charles mentioned the kind of online sandboxes, and the reason for demoing these 2 is I'm using online sandboxes, whereas for DDoS mitigation, I need a real forwarding plane, so I'd have to go into a real router somewhere. So the overview is just to sort of show where it fits in. So OpenDaylight, top right, the 2 plugins we're dealing with are BGP and PSEP. Originally, BGP and OpenDaylight was written specifically for BGP-LS. So BGP-LS is a way of getting link state routes out of your IGP, so out of OSPF or ISIS, and exporting them with BGP. But of course, the nice thing with BGP is once you've built it, because you add new address families really just as TLVs, you can just keep adding address families. And from an ODL perspective, and I guess from any SDN controller's perspective, the thing to remember is that we are not a router. We're interacting with routers. So what a router does with a RIB, with a set of routes, is it generates a FIB from it that it uses to forward packets. What OpenDaylight does with a RIB typically is generates a topology. And topology is the sort of the key abstraction. And Charles mentioned the model-driven thing. So we have a topology model that we implement in OpenDaylight, which is in the I2RS working group in IETF. And that model can then be specialized for different types of topology. So BGP-LS builds us a topology, so a graph of the network. Then PSEP we can use to program LSPs through the network, so MPLS LSPs. But as I say, we also have all these other address families. So processing of BGP routes in OpenDaylight is just like in any router. For each peer you build an adjacent ribbon, so that's all the routes this guy gave you. You then apply an import policy. Now currently in OpenDaylight there's very limited policy. I think you can have a policy to block everything or otherwise pretty much allow everything that's legal. And that generates an effective ribbon. I think there will be some work on doing more policy. But I think one thing again to remember is you're dealing with software. This isn't a router, so we can, in the Java code, interface directly into any of these different components that we want to. We can spin up as many ribs as we want to, and we can write our own code that takes stuff out of one rib and puts it into another. So it may not make sense to do topology in the usual sort of Cisco router topology case or sense. We then have the decision process. So I don't know if anyone here has ever worked in an internet provider or worked running networks. With BGP, did you have the list by your desk with the BGP decision process? Because I always had it like glued up next to my desk, this kind of local pref first, then wait and whatever. I've forgotten it all now. But so we had that decision process. And again, that's the sort of thing that we might want to make programmable because we're an SDN controller. Maybe we should let you write your own decision process rather than enforcing one on you. This is kind of a plea for developers at this point. So from that, we generate the local RIB. So and that is what we'll then use to generate topology. And we have one local RIB for all of our neighbors. Then we apply again a very simple export policy, and we generate an adjacent RIB out for each of our peers. Also, because everything's based on these Yang models, so it's a data modeling language, and models tend to either be instantiated as configuration state or operational. And the problem is the RIB's all operational data. So what we have to do is create like a special instance that we can configure. So this means that through REST-conf we can go in and we can push routes into the system. But as I mentioned before, because if you're coding inside the controller in Java, there's nothing that says you have to do that. You can write Java code that will poke stuff straight into one of the RIBs, whichever one you want. So then topology is generated. So in the BGP-LS case, that's effectively your OSPF or ISIS topology. But we also generate other topologies like the V4 and V6 ones, which are kind of a misnomer as a topology because there's no links. It's just nodes which are your next hops, and then for each next hop a list of prefixes. And again, because you can write these topology exporters, you can develop really whatever topologies you want. And I keep meaning to get around to doing like an ASN topology for ISPs that would show you the AS paths through your network. So yeah, topology model. So to my mind, this is the best way of doing a network level abstraction. And really, if you're doing anything in SDN in the broadest sense, what you need is a network level abstraction. Because if you're just going to operate on individual nodes, why on earth do you need a controller? The whole point is to get away from thinking about individual routers to thinking about the network as a whole. So what it is just a list of nodes, a list of links. Finally, it seems to be getting towards RFC, modulo a bit of politics and the ITF over it. As well as nodes and links, you have these termination points. And that's just a way of disambiguating interfaces. So, two routers have two links between them. You need to know which is which. In fact, all the links are unidirectional, and that's because you can have different metrics in different directions. I'm not a mathematician, but it is just graph theory. It also lets you layer one topology on another. So if you've built an optical topology and we're doing some work on that, you can then take an IP topology and layer it on top and say, this IP link depends on this optical link, which can be very useful. So in my former life as a service provider in a country that's quite long and skinny, the problem that you have is you have vast numbers of router-to-router links that end up going through the same fibers and the same ducts. So now if one optical link goes, you could lose a whole bunch of router-to-router links. But it's good to at least know which links depend on which optical links and be able to model that. So the model itself is very abstract. So what you then do is you kind of specialize it for whichever protocol you're dealing with. So for the link state stuff, we map stuff like router IDs into our node IDs, our link IDs, etc. But then we augment the model with like specific information from our protocols. So what that lets you do is sort of program to whichever level works for you. So if you just want to draw a topology in the network, you don't need to care if this is open flow or if it's link state. It's just a topology. But if you want to start messing with stuff, you might need to know, well, this is an IP topology. Or you might even want to know it's OSPF or ISIS. So what you end up with is this kind of dependency tree almost. We say we have the network topology. So in the new topology models that OpenDaylight's moving to, we actually separate the network, which is just the nodes, from the network topology, which has links in it. But then we effectively augment that to get a layer 3 unicast topology for link state, but that again gets augmented into OSPF or ISIS. So then you'll see things like router IDs will end up in the unicast topology, but things like your ISIS net ID is going to end up in the ISIS topology. And how that happens is we basically pull the roots out of the RIB through a topology exporter that pushes them into this topology. And really, again, this is all about sort of syntax and semantics. So what you want from a controller is easy interfaces for developers. Talking to RIB, you've got that because you've got REST and JSON. But the problem is the object you're looking at still has all the stuff in it that says, here's my local pref, here's my AS path, whatever it is. So you as a developer now have to understand BGP. Once you get to the topology, you've got some semantic change as well as syntax. And now you're actually seeing nodes and links, not seeing routes. And so in general, we'll see people working with that. So I mentioned the link state topology, and that one's the only one we get from BGP that actually has links in it. But the other one we're going to come on to is PSEP. So this is the path computation, how we push push paths into the network. So that's the first demo, which we're hoping will work. I did sacrifice a chicken. So I mentioned this thing about using different protocols, one to get information, one to push it in. So we're using BGPLS to get data out of the network. So now we know what our ISIS or OSPF topology looks like. Then we use PSEP to program MPLS label switch paths into the network. So what I've got running here, oops, wrong way. Let's minimize that. What I've got running here is an Ubuntu VM that's got OpenDaylight running in it. It's also got this application called Pathman SR. All this stuff's up on GitHub, so I can point you at that. Better find the right browser window. There you go. Aha. This will, of course, be the problem with changing resolutions. So what I have running in the sandbox in the cloud is a setup with 16 different virtual routers, neatly mapped onto approximately a map of the US. I just twiddled that manually while I was waiting to talk. And so you can actually, you can log into these. So literally from here, I can telnet into those routers if I want to. But what we're doing instead is we're going to set up a path through them. Oops, that's the last one I set up. Ha, great. I just go to that, don't I? So let's pick, I don't know, let's stick with Boston. Where are we going to go to? San Jose, maybe. So now what I do is I say, well, what's the metric I'm going to use? Do I want to use normal IGP metric, T metric, so the traffic engineering metric, or just count number of hops? Or in fact, I can go manually and just sort of draw the path across my network. What's sort of cute here with the algorithm is, so I do IGP metric and compute paths. So instead of Dijkstra getting a shortest path, this is Nijkstra, after my colleague Nicholas who wrote this, which gives you every possible path. So let's pick one that's probably fairly insane. Boston, New York, Chicago, Kansas City, Minneapolis, Seattle, San Jose. There you go, it's deployed. So now, if I list my paths, you can see that path in the network, and then I can just go in and delete it if I want. Yeah. So that's an example of an app that's sitting on top of OpenDaylight. The app itself, Pathman, is written in Python, but then it exposes a REST API northbound. From the web browser, it's using JavaScript. There's again, it's open source. There's like a library called NextUI that lets you do topology maps and things in JavaScript. And it's just using that to draw it out. But then the API adds things, commands for pushing paths into the network and that sort of thing. So let's get rid of that one. Back to demo or presentation. Right, so next use case is, so DDoS mitigation. So this is kind of a live issue for a lot of carriers, and we've had a fair bit of interest in people using controllers to do this. So the issue is, you've got a network, you've got some kind of DDoS attack. The issue is you don't want to be going in, you're under time pressure, so the last thing you want to be doing is going in and telnetting into each of your routers one by one to add ACL entries or anything like that. So what BGP now has is FlowSpec, which, oops. So BGP FlowSpec effectively lets you push, very much like OpenFlow, push like a flow match action rule into the network, but you're doing it through the BGP infrastructure. So now you've got the use of the route reflectors. So I can push it from a controller, and then, for example, every edge router on my network, if it's configured to import that community that I advertise these routes with, they'll all import that same rule. So instead of having to use OpenFlow and touch each one of them individually, we now touch them all in one go through BGP. So the question then is, how do you figure out that there's a DDoS attack going on? And I think this is one of the big trends we're seeing in networking. I think Charles sort of alluded to it, this issue of the amount of data that's coming out of the network. So in the old days, we used to poll things with SNMP. The challenge there is you just can't get the data out quickly enough. So what you need to do, or what you ideally want to do, is have some kind of streaming telemetry coming off the network where either events or time series data counters are being pushed through a collection infrastructure. And then what you typically do is put a message bus on the back of this, and then from that message bus you can feed multiple applications. And one of the applications that we typically feed is Panda, which there's a talk on this afternoon. So this is a platform for network data analytics. So great, we've now got all these analytics. So with a bit of machine learning foo, we can see that there's a DDoS attack going on. But the problem is, what do we then do about it? So that's where I would say the controller can come in. So you can build an API on top of the controller, which is now intent-based, and says, okay, I'm getting a DDoS attack from such and such an address on such and such a port, shut it down. The app making that call doesn't need to know what that involves. What it would involve in this case is OpenDaylight using BGP FlowSpec to push a flow rule into the network to drop those packets. This is actually in the wrong order, but just to give the FlowSpec overview. So yeah, very much like OpenFlow, but using BGP. What it lacks, because it's IP-centric, it lacks all the layer 2 stuff. So you can't match MAC addresses, because that's kind of meaningless if you're in an IP world. So having said that, OpenDaylight does now support the EVPN address family for BGP, which is about MAC addresses. So perhaps we should wind the IETF that they ought to put those in FlowSpec. And so in terms of actually blocking it, what you would do is you just advertise that FlowSpec route. So you'd have this RESTconf API that says, okay, shut this down. Some kind of app inside OpenDaylight. The BGP plugin would advertise the flow spec routes to the route reflectors, and those would then push it out to your PEs, and that would result in attack being stopped. I have got a demo for this somewhere, but as I say, it uses real routers rather than the sandbox. So the final demo, I want to quickly show how to zoom through these slides, I expect. So CDN localization. So what this comes down to is, have I gone the right direction? Oh yeah, this is just the overview of the protocol we're going to use, BMP. We didn't specifically have to use it for this, but the nice thing with BMP is that instead of, it's basically like BGP. I don't know anyone here has heard of BMP. Yes, there's a few. So it's like BGP, but the difference is that instead of just getting the local rib entries from your peer, you get everything your peer knows about. So all of that adjacent ribbon and effective ribbon I mentioned earlier, you get all of that data from your peer. It can be very handy at exchange points because you want to know what all of your peers have advertised to you. But equally on a route reflector, it can be really useful because then you get to see everything the route reflector knows about, not just the best routes it's selected. So the problem we're trying to address here is over-the-top video. So I think the US, I hear these stats, something around a third of all traffic is Netflix, a third is other OTTs, and a third is regular internet use. I know in other countries it's different. I hear in India it's like over 50% Google, this sort of thing. So there's very, very high volumes of this traffic. And of course, what you're always trying to do as an ISP is cut your cost. So what you want to do is have caches as close to your users as possible. The OTT providers are generally pretty happy to give you caches to push out into your network, and you can go on any of their websites and explain the process you have to follow. The challenge is, how do you figure out which is the right cache to use for a specific user? So typically these providers connect at the internet exchanges, but as I say, they also deploy caches into ISP networks. Quick confession, this deck doesn't have that in the reading list. I should have edited that. And really it comes down to two different problems. So the first one is, how do you know which prefix a user's on, which actually isn't that trivial, because you think about it with DNS, because DNS serves cache, you do a lookup, you don't actually know as the authoritative server, because the lookup from the ISP will only come once. You don't know who's asking for that address. You just know it's their resolver. So how do you map a user to a prefix? And then having done that, how do you figure out the right cache? And that's effectively what we're trying to solve here. In terms of mapping users to prefixes, Netflix do it because they have a portal. I know Akamai presented on this at SIGCOM last year, or the year before even now, about using DNS client subnet, where basically what you do is with a /1/25 granularity, every time a user in a different /25 asks for something, you actually send it to the authoritative server again, and you tag it with this client subnet to say this user's coming from this prefix. But in terms of the second problem, really it comes down to either BGP communities or MEDs. This is my understanding of what the top OTTs do. It may or may not be correct. But the issue is, if you're an ISP and you have this kind of structure in your network, and you're probably going to be tagging your different exchanges or, as Chris would have said, central offices, you're going to be tagging those with communities, and you're going to have a hierarchy. So your core nodes are going to be tagged one way, and your metros another, and the end exchanges another way. And so you'll tag your routes with these communities, but the question is, what do those mean for CDN provider? Because they have their own structure of communities typically. So what we want to do is do some kind of mapping from one to the other, either sort of offline, or we might even want to do it real time. So we might even want to say, we have this link state topology. We can use that to give information on our topology as the ISP and do sort of real-time changes to the over-the-top provider. The way we configure this is using this Yang model. So I mentioned Yang. So OpenDaylight, router platforms like Cisco ISXR typically have their own native Yang models. What we're seeing now is a migration towards common models. So both XR and ODL have implemented the OpenConfig Yang model. I think Juniper may have done it as well. So we're getting to a world finally where we have common shared models. So that's how we configure the mapping. And so you configure the mapping rules using RESTconf API. There's a mapping application inside ODL. The routes come in from the route reflectors using BMP. They flow into the mapping application. They also, via Kafka, flow out into Panda if you want to do analytics on them. And then from the mapping application, we push into the ribs, one rib for each of the different CDN providers because they can have different rules. And then the routes flow out to them. So that's the final demo. I'll just quickly show it. Oh. So I have to telnet back in. You can probably guess my username and password on this. Oops. Yeah. So what we have here is a /25 that we've tagged. So we've tagged it with community 65504 6500. And so what's happening then is this is flowing through a root reflector, which I'm not logged into OpenDaylight. The app in OpenDaylight is changing the communities. And then if we look at the route as it comes out again, it was 0.0, wasn't it? You can see the community's now been changed to, so the AES has changed, of course, but the actual semantics on the community have changed from whatever it was, 6500 to 1000. And we could do that across any sort of string of prefixes we wanted. And what you would find is if I add more prefixes here, if I don't tag them with the right community, they won't even make it through. So if I do a show, of course it's annoying, you have to add the routes, don't you? Let's go 2.0. I should be doing all this through netconf on ODL, really. It was 2.0, wasn't it? It's probably really foolish of me to try this live. Yeah, that won't be there, but hopefully the other one will. Haha, see, it isn't. Might take a while. Trust me to do a live demo and screw it up. Well, we'll give it a few minutes and then it'll turn up. That was very foolish of me. I may have killed the controller without looking. Yeah, I think that was pretty much it. The only thing I wanted to say was just, most of the stuff's up there on GitHub. So I've got a Git set up for this OpenDaylight setup, which includes all the scripts you need to get ODL up and running with netconf, BGP, PSEP, etc., including there's like a Vagrant box in there. So if you want to do it with Vagrant rather than just installing it. Then the Pathman SR thing is the app I mentioned that I showed. There's also a bunch of videos out there of these are ones I did at the ODL Summit last year, running demos that actually work and that sort of thing. So yeah, any questions? Sorry? Probably not yet, but I can put them there. Haha, it's made it. Good, good. Yeah, I'll make sure the slides go up online. Phew. Any other questions?